Good morning, students. Today we will discuss some miscellaneous concepts in graphs. So we know that already what is the degree of a vertex. Okay. So this is already we have discussed, that is what is the degree of vertex. So coming to the degree of vertex, nothing but here suppose this is some graph like this. Here this is A, B, C, D. What is the degree of this one? That means here this is the vertex and this is another vertex, this is another vertex, this is another vertex. So there is an edge from here to, sorry, there is no direction. So this is what some graph. So for this, what is the degree? So what is the degree of this vertex? So this degree of this vertex is what? For A, degree is 5. Why? Because here 1, 1, 2, 3 are the vertices. Here 1, 2, 3. Now this is a self loop. So self loop repeats, self loop counts twice. Self loop count twice. So that's why. So degree of this A is 5 and B 1 and C 1 and D also 1. So total how many? That is what is the degree of this vertex? 8. And coming to, suppose if there is no self loop like this. Here suppose there is no self loop. So if there is no self loop, then what is the degree? So degree of A is what? In that case, if there is no self loop, degree is 3. So here what? B, C 3. That means then the degree is what? 6 only. That means self loop is count how many number of times? That is twice. Self loop counts the twice. Okay. So this is what the degree of the vertex. And next, now coming to next concept, that is regular graph. We know that a regular graph is nothing but each and every vertex degree is same. Then we can call it as a regular graph. Then we can call it as a regular graph. Now, so here you can observe what is the regular graph. Suppose here regular graph in the sense, now here regular graph. What is the regular graph? So regular graph in the sense what? That means suppose here A, B, C, D, E. So these all are the vertices. Now suppose this is what? And now this is, and this we can call as a regular graph. So this is what the regular graph. This is what the regular graph. Now suppose you can observe this is what? This is also regular graph. So this is also regular graph as well as complete graph. This is called as a complete graph. But this is not a complete graph. What is the difference between this? Not complete graph. Why? Because the coming to the complete graph. So suppose you can take this vertex. So this vertex adjacent to all other remaining vertices in the graph, then only we can call it as a complete graph. Otherwise, if the graph vertex degree is same, each and every vertex in the graph the degree is same, then we can call it as a regular graph. Coming to the complete graph, so you can, if you can take one vertex, that vertex adjacent to all the remaining vertices, then you can call it as a complete graph. Suppose you can observe here, this is A, this is B and this is C. Suppose you can take here, each and every vertex degree is 2 here. And so how many number of vertices are there? 3 vertices are there. So each and every vertex degree is what? 2. That means what? 2 minus, that 3 minus 1. That means here every vertex, that means every vertex, suppose if a graph contains n number of vertices, so every degree, every vertex degree is same, that is what? Regular. That is what? Regular. Suppose if graph contains n vertices, so each and every vertex, each and every vertex degree is n minus 1, then we can call it as, complete graph. Complete graph. That is what the concept. That means, so if you can observe here in this figure, suppose you can observe here this figure. Suppose you can observe this figure. Here n number of vertices, that means 3. So each and every vertex degree is 2. Suppose whereas you can observe this graph, here 5 vertices are there. Suppose if it is a graph, so then what is the degree here? Each and every vertex degree is 4. So total degree is what? N into n minus 1. So total degree for the graph is n into n minus 1. That is 5 into 4. That means 20. So all vertices degrees sum chesam anukondi, that gives as a 20. Whereas regular graph lo enti, suppose n number of vertices are there, equal degree. Suppose in that case we are not find out how many are there. This is not possible. Why? Because here it gives a total. That means in the regular graph we cannot find out how many number of vertices. So how many number of edges? Because that is what impossible. Because sometimes it adjacent with 2 vertices. Sometimes it adjacent with 3 vertices. That means maximum possibility we can find out, but exactly we are not find out. Okay. So whereas coming to the complete graph, we can find out exactly how many number of edges are there. So on this topic, we can expect the questions in exam. Okay. Next concept, that is so next concept is what? Order and size. What is the order of the graph and what is the size of the graph? So coming to the order and size, here so coming to the order, that is, what is the order? What is the order? That is order in the sense what? This is also one of the question. They can give the question like this. So graph is given, find out the order. what is the order? So coming to the order in the sense, order means how many number of vertices, in the graph, that is nothing but order. So that is represented like this, order of the graph equal to, suppose this is the graph like this. Now, so this is some graph, but in this case, what is the order of this one? Is the order is 4 here. Now the order for this graph is 4. Okay, and now coming to the size, what is the size of the graph? So number of vertices, so number of vertices in the graph, nothing but size. Number of, that is order in the sense number of edges, and coming to the size equal to number of vertices. Order in the sense number of vertices. Suppose here one more vertex is there, then what is the order? That is 5. So coming to the size, that means number of edges. So size equal to number of edges. Number of edges equal to here, how many number of edges are there? Only 4. That means size equal to 4 only. Okay. Suppose if the graph is like this, here the graph is like this, A, B, next C, D, next E. So here one more self loop is there. Then what is the order? Order equal to what? 5. Order equal to 5. And coming to the size, here suppose one more vertex is like this, then order equal to what? Here 6. And coming to the size equal to, that means n equal to, this is also represent like this, n equal to 6, and number of edges, there is nothing but size equal to what? 1, 2, 3, 4, 5. Self loop can count twice, that is nothing but 7. N equal to 6 and E equal to 7. And next here summation of degree of vertex equal to, here one important point for this, summation of degree of all vertices equal to twice the number of edges. So we know that is in the undirected graph. So degree sum, how we can find out the degree sum? Sum of degrees sum equal to twice the number of edges. Okay, suppose here, that is how this is represented, sum of degrees. So for all u belongs to G, that means u is nothing but some H belongs to G, sorry, some vertex. So this vertex belongs to G. So this u takes from vertex set V, and degree of V equal to 2 into number of edges. So this is only for undirected graph. This formula is only for undirected graph. In the undirected graph, sum of edges equal to twice the number of vertices. Suppose for example here, this is one graph A and B, next C, next D. This is one graph. So from here to here, one more graph is there, and here one self loop is there. Now from here to here one edge is there. So here 2 more vertices, that is E and F. So this is the graph. So in this graph, what is the order? Here order equal to what? Here order equal to what? Coming to the order equal to 6. And coming to the size, what is the size here? How many number of edges are there? You can count here. That means here number of edges, okay, number of vertices adjacent to here, that is not the that means coming to the undirected graph, we are not saying that number of adjacent vertices. So sometimes between same vertices, more number of edges also there. So this graph is called as multi-graph. So in the multi-graph, suppose here, what is the degree of this one? That is 3. Here 3. And next here, how many number of edges are there? 1, 2, 3, 4. Here 4. Next here what is the degree of this one is 2. And what is the degree of this D? Degree of D is what? 1, 2, 3 and self loop. That means total degree is 5. And coming to vertex E, 1, and coming to F, degree is 1. Okay. Then how many number of edges are there? So now you can observe here, this is 1, 2, 3, 4, 5, 6, 7 and one self loop is there. One self loop is there. That means total how many number of edges are there? That means total ga any edges untayi manaki ikkada? Only one edge. Here 1, 2, 3, 4, 5, 6, 7, 8, 9. That means size equal to 9. Order equal to 6 and size equal to 9. So sum of degrees is equal to what? Sum of degrees equal to what here? For all V belongs to G and this V is belongs to in the vertex set. That means here degree of V equal to sum of degree of V equal to what? That means sum of degree of this one is 3 plus. Now B degree is 3. Sorry, B degree is 4. Next C degree is 2 and D degree is 5 and E is 1 and this is 1. That means how many number of total you can count here? That means 3 plus 4 7, 7 plus 2 9, 9 plus 5 what? 9 plus 5 14 and 15 16. Here 16. So whereas coming to the edges, that means here edges are, this is, even though this is the self loop, okay, we have self loop, but whereas for counting, that means ikkada meeku idi enduku inta stress chestunnamo ante size find out chestunnappudu you can take it as only one edge. Even though if the self loops are occurred, you can count it as only one, while you can find the degree of that particular vertex, then you can count it as twice. Okay, degree చెప్తున్నప్పుడు మాత్రమే, that means number of edges means 1 2 3 4 5 6 7 8 అంటే కమింగ్ టు ద సైజ్ ఈజ్ ఓన్లీ 8 అంటే ఇక్కడ మనం 9 తీసుకోవడానికి లేదు, బికాస్ ఎడ్జెస్ చెప్తున్నప్పుడు దీన్ని ఒక్క ఎడ్జ్ గానే కౌంట్ చేసాము, డిగ్రీ చెప్తున్నప్పుడు మాత్రం ట్వైస్ గా కౌంట్ చేసాము. ఓకే, సో దట్ ఈస్ ద ఇంపార్టెంట్ వన్. ఓకే, సో మీరు ఇక్కడ ఏంటి సైజ్ ఈక్వల్ టు హౌ మెనీ నెంబర్ ఆఫ్ హౌ మెనీ నెంబర్ ఆఫ్ ఎడ్జెస్ ఆర్ దేర్. సపోజ్ ఇక్కడ ఎన్ని ఎడ్జెస్ ఉన్నాయి ఫస్ట్ ఫైండ్ అవుట్ చేయండి. 1 2 3 4 5 6 7 8. సో ఎడ్జెస్ వచ్చేసి 8. అంటే ఇక్కడ మీరు అడగచ్చు సెల్ఫ్ లూప్ ఉంది, బట్ దెన్ దిస్ ఈస్ కౌంట్ యాజ్ ఎ 2. బట్ వెరాస్ కమింగ్ టు ద డిగ్రీ ఆఫ్ దిస్ పర్టిక్యులర్ వర్టెక్స్, దెన్ ఓన్లీ if there is exist any self loops we can find out what twice, otherwise we can find we can count it as only 1. అంటే ఎడ్జెస్ గా కౌంట్ చేసినప్పుడు మాత్రం 1 గానే తీసుకుంటాము, బట్ మనకి వర్టెక్స్ కౌంట్ చెప్తున్నప్పుడు డిగ్రీ చెప్తున్నప్పుడు మాత్రం ట్వైస్ గా ఇస్తాం. దట్ ఈస్ నథింగ్ బట్ ఇక్కడ ఏంటి డిగ్రీ చెప్తున్నప్పుడు మాత్రం దిస్ డి డిగ్రీ ఈజ్ టోటల్ డిగ్రీ ఈజ్ 5, బట్ ఎడ్జ్ మాత్రం ఏంటి ఓన్లీ 1 ఎడ్జ్. Here now this is what the order and size. So ikkada manaki this is the important formula. So this one is the important formula here. Okay, this is the important formula. Okay, that is sum of degrees equal to 2 into number of edges. So but edge count is only one time if there is exist any self loops. ఒకవేళ సెల్ఫ్ లూప్స్ వచ్చినా కూడా ఎడ్జ్ కౌంట్ మాత్రం 1 ఉంటుంది, బట్ డిగ్రీ కౌంట్ మాత్రం ట్వైస్ ఉంటుంది. ఓకే, దెన్ నెక్స్ట్ another topic. So this is what the important question. Suppose they can give the question like this type of questions. So find out how many number of edges, what is the degree. So then next another one, how we can write the degree sequence. Suppose we can write the degree sequence for this. So degree sequence means how we can write this degree sequence. Degree sequence ela issamu ante ascending order. That is, suppose in this graph, so 6 vertices are there. So what is the degree sequence of this one? 1 1 1 1, that is 1 1, next 2, next 3, next 4, next 5. So this is what the degree sequence. That means number of, so degree sequence is like this. So you can observe here number of vertices are 6. Okay, in this each and every vertex degree is like this. Then this is what the degree sequence. Okay, now this degree sequence chesna kuda what is the sum of degrees. Okay, now next, suppose if the same concept ni how we can represent for undirected graph. Suppose if the undirected graph, now so this is the undirected graph. Now V belongs to G for all. Here degree minus V equal to summation of, for all V belongs to G, degree of V equal to number of edges. So this is for directed graphs. So in the previous one is for undirected graph. So this is for directed graph. That means here minus in the sense in degree. That means this is nothing but in degree equal to out degree equal to number of edges. So okay, graph low, that means if the given graph how many number of edges are there, that means in the given graph number of in degrees equal to number of out degree equal to number of vertices. That means here this in degree plus, that is you can add this in degree sum plus out degree sum. In degree sum and out degree sum equal to 2 into E. 2 into E. 2 into E, that is in degree plus out degree equal to 2 into E. In degree plus out degree equal to 2 into E. That in degree plus out degree equal to 2 into E means, suppose if it is the undirected graph, that is total degree of each and every vertex equal to 2 into twice. If it is the directed graph, in degree plus out degree equal to 2 into E. Okay. Now, so see the example for this. Suppose here this is some graph A, B, C, D. Here A to B some edge is there, and so here this is one edge, and next here this is both directions B to D as well as A to B to D as well as D to B. Next here both here degree edge from D to C, and then next here D. Next here C to A edge is there. Now find the in degree for this one. That means A, B, C, D are the vertices, and now find the in degree and out degrees. What is the in degree for this A? How many number of edges are instant to A? That is only one edge, that is from C to A. Here C to A, in degree of A is 1. Coming to the out degree, how many number of edges are instant from this vertex A? That means only one edge, that is from A to B. Here out degree is also 1. So, and coming to the B, what is the in degree? So for B in degree is what? That is how many number of vertices are edges are instant here? That means 1, 2, 3. It means here 1, 2, 3. That means in degree is 3. And coming to the out degree. So coming to the out degree, here one edge is from B to B. Okay. In degree and out degree both are there if the self loop is there. So this is what B out degree is 1, and coming to the in degree from B to D, 1 vertex is. So what is the total of this one? So 1 plus 3 plus 1 plus 2. That is what? 4 plus 5 plus 7. Here 7. Here what? Here also. No. Here also 7. This is also 7. That means in degree 7 and out degree 7. And coming to the number of edges. Suppose you could order entandi. What is the order here? Only order of this one is 4. And coming to the size of this directed graph, 1, 2, 3, 4, both directions. So that you can count it as a 2 times. That means 1, 2, 3, 4, 5, 6. 6, and this is counted as a 2 times because it is the both directions. Okay, that means 7. That means how many number of that means in degree equal to 7 and out degree is also 7 and number of edges also 7. So this is the formula for directed graphs. So in the directed graph, in degree equal to out degree equal to number of edges. So this is also one of the concept for this is the important concept. So find this is the important one. Means here you can count it as a 2 edges. Okay. Now, so every graph has unique in degree and out degree. So this is one of the important one. So suppose you can observe here every graph. So it has unique in degrees and unique out degrees. Okay. Next here there is in every coming to the in every undirected graph. Now here one important point, that is in undirected graph every in undirected graph number of out degree, that is number of odd degree is always even. Number of odd degree is always even. That is number that means here number of odd degree vertices is always even. Okay, suppose here like this, number of odd degree vertices like this. Here you can observe this is what 3, here 1 and here 1, and suppose you can take it like this. Okay, here this is a vertex, here a number of odd degree vertices. Suppose this is also odd degree and this is also odd degree, this is also odd degree and this is also odd degree. Okay, so now you can count all these ones. So here how many number of vertices are odd degree vertices are here? 4. Suppose you can this. So in this case, what is the degree of this one is 3 and degree of this one is 2 and degree of this one is 2. And coming to this, how many number of vertices are odd degree? That is only here in this case. In the second case, 2. Okay, A and D are the odd degree vertices. That means suppose you can take any undirected graph, number of odd degree vertices is always even. So number of odd degree vertices is always even. That means suppose A graph తీసుకున్నా కూడా number of vertices odd degree vertices ఉన్న count find out చేసినాం అనుకోండి, that gives as, suppose you can observe here, what is the degree here? 2, here 1, here 1. So now in this graph, number of vertices, how many number of vertices with odd degree? That means B and C vertices with odd degree 1. సో అలా మీరు ఏ గ్రాఫ్ తీసుకున్నా కూడా ఇన్ అన్డైరెక్టెడ్ గ్రాఫ్ నంబర్ ఆఫ్ odd degree vertices is always even. So this is one of the important point in undirected graph. So coming to the directed graph, every graph has unique in degree and out degree. So every undirected graph అంటే unique in degrees and unique out degrees ఉంటాయి. సో సేమ్ అనేది ఉండదు. సో యూనిక్యూగా అంటే సపోజ్ యూ కెన్ అబ్జర్వ్ లైక్ దిస్ A to B and C, suppose here like this. Suppose you can observe here. So 1, 2 comma 1, and here what is that 1 comma 1. Here what in degree 0 and out degree 2. So suppose you can observe all these vertices in degree and out degrees are unique. So for each and every vertex unique in degrees and unique out degrees are there. So this is one of the important point. That means every vertex in undirected graph has unique in degrees and unique out degrees, whereas in undirected graph suppose you can count the odd degree vertices. You can count the odd degree vertices, those are always even number of vertices. That means suppose you can take this graph. So how many number of vertices are even number of, suppose here like this, suppose like this. So in this case what, this is a 4, but even number of vertices with odd degree is only 2. That means always even number. Okay, next. Coming to the another point. So number of vertices. That means no graph can have odd number of vertices of odd degree. So that దీన్ని బేస్ చేసుకొని మనం ఏం పాయింట్ చెప్పొచ్చు, no graph can have odd number of vertices with odd degree. Odd degree అనేది ఉండదు. ఓన్లీ odd degree ఉంది అంటే ఖచ్చితంగా odd degree ఉన్న vertices ఎన్ని ఉంటాయి మనకి అంటే ఈవెన్ నెంబర్ ఆఫ్ vertices ఉంటాయి. సో there is no odd number of vertices. Why? Because in undirected graph we can count it as a twice. That's why. So if the graph contains odd degree vertices, always even number of vertices. That means suppose you can observe here 1 and 1. That means you can take here. Suppose like this. So here 2, here 1. How many total vertices? 3 ఉన్నాయి. ఇందులో మనకి odd degree ఉన్న vertices ఎన్ని ఉన్నాయి? That means 2 ఉన్నాయి. That means even number. Odd degree vertices ఉన్న vertices ఎన్ని ఉంటాయి అంటే even number of vertices ఉంటాయి. Okay, next point. So in a simple graph n vertices are there. Suppose in a simple graph in the sense what andi, there is no self loops as well as there is no multiple edges కానీ self loops కానీ లేకపోతే we can call it as a simple graph. So in the simple graph n vertices can have at most how many number of edges, that is n less than or equal to, sorry, ee kada, number of edges less than or equal to n into n minus 1 by 2. At most how many number of edges are there? If the graph is simple graph, so for example if the graph is simple graph, then if graph is simple graph, so simple graph, then how many number of edges are there? Those edges are n into n minus 1 by 2. At most maximum ఎన్ని edges ఉంటాయంటే n into n minus 1 by 2. Suppose you can observe here, this is what the simple graph. Okay, how many number of vertices here? 3 into 3 minus 1 divided by 2. That means maximum ఎన్ని vertices ఉండొచ్చు మనకి, sorry, ఎన్ని edges ఉండొచ్చు, only less than or equal to. That's why less than or equal graph like this, A, B and C. So this is the graph. So in this case how many number of edges are there? Only 1. So here number of edges are 2. So now how many number of edges here? 3. So that we can call as less than or equal to 3. 1, 2, 3. So maximum ఎన్ని edges ఉండొచ్చు అంటే 3. Minimum 1. Minimum 1 and maximum, that means sometimes 0 also. That is G, A, B, C. So in this case there is no edge. 0 less than or equal to n into n minus 1 by 2. That means 0 less than or equal to 3. isn't it? That means suppose here the graph is, this is one graph, this is one graph, and this is, sorry, this is the another graph, and next this is the another graph. So here the graphs are like this. Here this is one graph and this is one graph. The graphs are like this. So in this case, this graph size is 0, this graph size is 1, this graph size is 2, this graph size is 3. So that's why how many number of maximum, how many number of edges are there in the simple graph? That is 3. Means n into n minus 1 by 2. Okay, this is what the one of the property. That means if the graph is simple graph, then at most that graph exists how many number of edges? That is e less than or equal to n into n minus 1 by 2. And suppose if it is e equal to n into n minus 1 by 2, the number of edges equal to 3 into 3 minus 1 by 2 means 3. So then it is called as complete graph. Then it is called as complete graph. So how many number of edges untai complete graph lo manaki? If it is a undirected graph, n into n minus 1 divided by 2. If it is a directed graph, n into n minus 1 by 2. Already we have discussed this concept. That means if it is a directed graph, maximum it exists n into n minus 1 by 2. If it is a directed graph, n into n minus 1 by n into n minus 1. Next, here, so suppose coming to complete graph, Kn is a complete graph. So here in this case, complete graph in the sense what? So complete graph in the sense, suppose K0. K0 means there is no vertex. Okay, sorry, there is no K0. K1 means only one vertex. There is no edge. There is no edge. Suppose K2. This is. So here how many number of vertices, edges are there? Only 1. That means n into n minus 1 by 2. Means 2 into 2 minus 1 by 2. 2, 2. So that is only 1. Suppose if it is a k equal to 3, like this. Now, how many number of 3? 3 means what? 3 into 3 minus 1 by 2 means this is what? 3. So that if it is a kn, n into n minus 1 by 2. If it is a kn, how many number of vertices, edges are there? Equal to n into n minus 1 by 2. Suppose if it is a k4. K4 nothing but 1, 2, 3, 4. So now edge from this vertex to this vertex and this vertex to this vertex and this vertex to this vertex means, so if you pick one vertex, that vertex is adjacent to all remaining vertices. So now from here to here, here to here and here to here. Suppose you can take this one, from here to here edge is there, from here to here edge is there, from here to here edge is there. Suppose you can pick this one, edge from all this. So that n into n equal to here what? 4. That means how many number of edges here? 1, 2, 3, 4, 5, 6. So 6 size equal to 6. How we can get this one? N into n minus 1. That is 4 into 4 minus 1 by 2. That is 2. 2 into 3. Nothing but 6. That is number of vertices in the graph, in the complete graph is n. So then how many number of edges are exist? That is n into n minus 1 by 2. Okay, if it is a simple graph, less than or equal to. If it is a complete graph, n equal to n minus 1 by 2. Now, so number of, that means no graph of odd degree can be regular. How it is? That means, suppose here no graph of odd degree, odd degree can be k regular. K regular means K is a complete graph. Regular in the sense, what is the degree? Okay, degree of each and every vertex. In the complete graph also, complete graph, that means every complete graph is a regular graph, but every regular graph is not complete graph, isn't it? Suppose here you can observe this is what the a regular graph. This is what the regular graph. G1 is a regular graph. Suppose I am writing like this. This is what the G2 graph. Now this is the complete graph. So this is what the complete graph. So this is a regular graph and this is the complete graph. So then what is the difference between these two? Here you can observe each and every vertex degree is same. Then we can call it as a regular graph. Whereas every vertex is adjacent to remaining all other vertices, then the graph is called as a complete graph. In both of these two cases, degree is same. Degree is same. That means if it is a k regular, then this is a complete graph. Okay. That means every complete graph is a regular graph. Every complete graph is a regular graph. Every regular graph is not complete graph. So this is the important point. And now here, no graph of odd degree can be k regular. No graph of odd degree can be k regular. Odd degree means, sorry, not odd degree, odd order. Sorry, odd order. Odd order in the sense, suppose you can observe, this is the complete graph, isn't it? This is the complete graph. Okay. No graph of odd degree can be k regular. This is the complete graph. So, sorry, this is the complete graph. You can observe here, here 2, here 2, here 2. Suppose you can take this as D, here this is what k regular. Suppose I can take it as B. Now, odd order. Odd order like this. Okay, odd order can be k regular. No graph of odd degree can be k regular. Suppose now you can observe here, this is what odd degree. So odd degree, in this case this is the odd degree only. Sorry, not odd order. Order is 5. That means how many number of vertices? 5. Can be k regular. No graph of odd order can be k regular. K regular. So that means k regular means here what andi? K regular antunnadu. Ante k ikkada 5 undi. So but ikkada complete graph kaadu. Just it is only k regular graph maatrame. This is not a complete graph. Okay. అప్పుడు అంటే ఆడ్ డిగ్రీ ఉంది అనుకోండి, ఆడ్ ఆర్డర్ ఉంది, అప్పుడు అది ఆడ్ ఆర్డర్, దిస్ ఈజ్ వాట్ ఆడ్ ఆర్డర్ 5 మీన్స్ ఆర్డర్ ఈజ్ 5 ఈజ్ రెగ్యులర్ మాత్రమే అవుతుంది కానీ కంప్లీట్ అనేది కాదు. ఓకే, కంప్లీట్ అనేది ఇలా ఇచ్చినాం అనుకోండి, దిస్ ఈజ్ నాట్ కంప్లీట్. సపోజ్ మీరు ఇక్కడ అంటే ఇలా తీసుకున్నాం అనుకోండి, అప్పుడు ఇది నౌ ఇట్ ఈస్ ఏ కంప్లీట్ గ్రాఫ్. అంటే నో గ్రాఫ్ ఆఫ్ ఆడ్ ఆర్డర్ కెన్ బి కే రెగ్యులర్. ఓకే, నెక్స్ట్ అంటే కే డిగ్రీ అన్నట్టు, కే డిగ్రీ. నెక్స్ట్ హియర్ ద కే రెగ్యులర్ గ్రాఫ్ ఆర్డర్ హ్యాస్ హౌ మెనీ నెంబర్ ఆఫ్ vertices? Suppose ikkada k regular graph order n. Suppose if it is a k regular graph and regular in the sense degree here, graph of order n, then how many number of edges? So appudu edges n untai, n into k divided by 2. That means suppose A, B, E, C, D like this. Now n equal to 5 and each and every vertex degree is what? So every degree, k regular lo degree is 2 divided by 2. That means how many number of edges and only 5. So ikkada k degree nothing but k degree or k regular nothing but k degree or k regular nothing but what is the degree? So ikkada idi degree enta andi? This is 2, this is 2, this is 2, this is 2, 2 is 2. Okay, in this case ఒకవేళ ఆడ్ డిగ్రీ అయితే సపోజ్ ఇలా ఉంది అనుకోండి, నౌ ఇట్ ఈస్ 3. No. Okay. ఇప్పుడు ఇది రెగ్యులర్ గ్రాఫ్ కాదు. ఇట్ ఈస్ నాట్ రెగ్యులర్ గ్రాఫ్. సపోజ్ ఇక్కడ మీరు డి అబ్జర్వ్ చేశారనుకోండి 4 ఉంటుంది. ఇట్ ఈస్ నాట్ ఏ రెగ్యులర్ గ్రాఫ్. ఓకే, అంటే రెగ్యులర్ గ్రాఫ్ అయి ఉండి ఆడ్ డిగ్రీ వర్టిసెస్ ఉన్నాయనుకోండి, అప్పుడు ఎన్ని ఎడ్జెస్ ఎగ్జిస్ట్ అవుతాయి అంటే 5 వర్టిసెస్, దట్ ఈస్ n ఇంటూ k డివైడెడ్ బై 2. సో ఇఫ్ ద గ్రాఫ్ ఈస్ ఆడ్ ఆర్డర్ with k regular, then number of vertices, that means if graph is odd order with k regular, then number of edges equal to n into k divided by 2. So ikkada odd order, that means n, odd order, n equal to odd number, n into k divided by 2. So 5 into, so ikkada k degree means degree ka 2, for example 2 divided by 2, appudu em avutundi manaki 5. Okay, so this is one of the important concept. So then next one more theorem, that is suppose one more thing, if it is a planar graph, so k regular graph order equal to this, and number of edges in planar graph. Suppose if it is a planar graph, how many number of edges are there? అంటే ఇది ప్లేనార్ గ్రాఫ్ అనుకోండి. సో అప్పుడు ఎన్ని ఎడ్జెస్ ఉంటాయి? దట్ మీన్స్ దిస్ ఈజ్ ద ప్లేనార్ గ్రాఫ్, అంటే ఇక్కడ ఇది ప్లేనార్ గ్రాఫ్ అయి ఉండాలి. దట్ ఈస్ సపోజ్ హియర్ A B C D E. Now it is the planar graph, then only it is possible. సో ఇవాళ మనకి ఇది ప్లేనార్ గ్రాఫ్ అంటే ఇక్కడ ఈ కేసులో చూడండి. సో ఇక్కడ డిగ్రీ సేమ్ ఉంది, బట్ ఇక్కడ అంటే నేను ఇక్కడ ఏమి ఇస్తున్నాను, డిగ్రీ 3 ఇస్తున్నాను, CDE. సపోజ్ మై ఇంటెన్షన్ ఈస్ హియర్ దిస్ ఈస్ డిగ్రీ 3 అండ్ దిస్ డిగ్రీ. సో నౌ దిస్ డిగ్రీ 3, సపోజ్ ఇక్కడ డిగ్రీ దీనికి 3 అన్నాం అనుకోండి, అంటే ఇక్కడ ఇది 3 అవుతుంది. సో నౌ యూ కెన్ అబ్జర్వ్ దిస్ 1 2 3, ఇక్కడ కూడా 3, ఇక్కడ కూడా 3. సపోజ్ ఇక్కడ మీకు 3 అంటే ఇది రెగ్యులర్ గ్రాఫ్ కాదు. సో దీన్ని రెగ్యులర్ గ్రాఫ్ చేయాలి అంటే ఖచ్చితంగా ఏమవుతుంది, సపోజ్ ఇక్కడ ఇలా ఇచ్చినాం అనుకోండి, హియర్ 3 బట్ హియర్ వాట్ 4 ఈజ్ మిస్సింగ్. ఇంటీరియర్ రీజన్స్ ఆర్ 3 అండ్ ఎక్స్టీరియర్ రీజన్ ఈజ్ 1. ఒకటి ఎక్స్టీరియర్ రీజన్ ఈజ్ 1, ఇంటీరియర్ రీజన్స్ ఆర్ 2. సో దెన్ టోటల్గా ఎన్ని రీజన్స్ ఉన్నాయి? 4 రీజన్స్ ఉన్నాయి. సో దిస్ ఈజ్ ఈక్వల్ టు, సో హౌ మెనీ నెంబర్ ఆఫ్ ఎడ్జెస్ హియర్? 6 edges. Okay, 6 edges, and 6 edges minus order is what? 4. And what is the degree? What is the regularity? That means here you can take the regularity here 3. Okay, what is this? K regular, that means here 1 2 3. దట్ మీన్స్ ఎవ్రీ గ్రాఫ్ తీసుకున్నా కూడా మీకు ఏమవుతుంది, ఇక్కడ రెగ్యులారిటీ ఈస్ 3. దట్ మీన్స్ సో టోటల్ ఎడ్జెస్ ఆర్ 6 minus 4, 2 2 plus 3 5. ఓకే, నంబర్ ఆఫ్ రీజన్స్, ఎన్ని రీజన్స్? 1 2 3 4. సపోజ్ ఒకవేళ ప్లేనార్ గ్రాఫ్ అనుకోండి, హౌ మెనీ నెంబర్ ఆఫ్ రీజన్స్? గ్రాఫ్ ఇట్స్ అ ప్లేనార్ గ్రాఫ్, నెంబర్ ఆఫ్ రీజన్స్, ఇన్ దిస్ కేస్ నెంబర్ ఆఫ్ రీజన్స్ ఈక్వల్ టు, ఇఫ్ ద గ్రాఫ్ ఈస్ ప్లేనార్ మీన్స్ దెర్ ఈస్ నో క్రాస్ ఓవర్స్ లేవనుకోండి, దెన్ వీ కెన్ కాల్ ఇట్స్ అ ప్లేనార్ గ్రాఫ్. సపోజ్ A to B అండ్ హియర్ C, హియర్ D. నౌ దిస్ ఈజ్ వాట్ ద ప్లేనార్ గ్రాఫ్. ఓకే, సో దిస్ ఈజ్ వన్ ఇంటీరియర్ రీజన్, దిస్ ఈజ్ ద ఎక్స్టీరియర్ రీజన్. బయట ఉన్నదంతా కూడా ఎక్స్టీరియర్ రీజన్. సపోజ్ హియర్ నంబర్ ఆఫ్ ఎడ్జెస్ ఈక్వల్ టు వాట్ అండి? నంబర్ ఆఫ్ ఎడ్జెస్ ఈక్వల్ టు సైజ్ ఈక్వల్ టు 5 అండ్ నంబర్ ఆఫ్ వర్టిసెస్ ఈక్వల్ టు 5 అండ్ డిగ్రీ ఈక్వల్ టు 2. దట్ మీన్స్ 5 E minus n plus k equal to R. That is here how many number of 5 minus 5 plus 2 equal to number of reasons equal to 2. 2 equal to 2 అంటే ఒకవేళ ప్లేనార్ గ్రాఫ్ అయితే number of vertices number of edges number of vertices plus number of degrees and number of edges equal to what? 2. So equal to r. Suppose number of vertices minus number of regions plus regular equal to number of edges. ఇది కూడా ఫార్ములా. సో ఇది సాటిస్ఫై అవుతుంది, ప్రతిసారి మనకి ఇది సాటిస్ఫై అవుతుంది. సపోజ్ ఇఫ్ ఇట్ ఈస్ ద ప్లేనార్ గ్రాఫ్ లైక్ దిస్ CD. So this is the planar graph. Okay, so this is also planar graph. Here R1, R2, R3, R4. Okay, so the number of regions equal to entandi. So ikkada order equal to enta, order n equal to 4 and degree 3 and number of vertices 6. Okay, so how many number of regions are there? ఇక్కడ నెంబర్ ఆఫ్ రీజన్స్ ఎన్నండి మనకి 6 2 + 3 5 ఇక్కడ మిస్ అవుతుంది 1 2 3 4 5 6 రెగ్యులర్ 3. ఓకే, సో దిస్ ఈజ్ సాటిస్ఫైడ్ ఓన్లీ ఫర్ సో దిస్ ఫార్ములా అంటే e minus n plus k equal to number of regions. This is satisfied only for regular graphs. సో దీని నుండి మనం చెప్పేది ఏంటి అంటే ఓన్లీ రెగ్యులర్ గ్రాఫ్ మాత్రమే ఈ ఫార్ములా సాటిస్ఫై అవుతుంది. సో దిస్ ఈజ్ నాట్ సాటిస్ఫైడ్ ఫర్ కంప్లీట్ గ్రాఫ్. ఓకే, సో ఇక్కడ మీరు అబ్జర్వ్ చేస్తే సో నంబర్ ఆఫ్ vertices ఆర్ 4 అండ్ ఎడ్జెస్ ఆర్ 6 అండ్ రీజన్స్ వచ్చేసి 4 reasons, but we got here 5. Okay, 2 + 3 5, but the reasons are only 4. Okay, so this is only for number of it is satisfied only for planar graphs. That planar graph is a regular graph, not a complete graph. అప్పుడు మాత్రమే ఈ ఫార్ములా సాటిస్ఫై అవుతుంది. సో దిస్ ఈజ్ వాట్ ద కాన్సెప్ట్ ఆఫ్ కంప్లీట్ this is for some of the formulas. So in the next class we will discuss about some theorems. So those theorems are also depends on the degrees. That means small delta and capital delta. So this paina వీటిపైన మనకి కొన్ని ప్రాబ్లమ్స్ ఉంటాయి. Then we can discuss about the different operations on the graphs, and after that we can discuss about what is the diameter and what is the connectivity. So some problems regarding these graphs we can discuss. So I will post these notes also. So we'll stop.